Hello everyone. In this video, we'll be talking about marginal log likelihood, which is used as a cost function in most of the OpenQA settings. And along with that, as an explanation, we'll also talk about marginal probability and log some exponential function which we use to implement marginal log likelihood. So, as I said, marginal log likelihood is used as a cost function in most of the OpenQA. Put simply, it is nothing but minus log of marginal probability of correct answer. It is quite similar to negative log likelihood, which is nothing but negative log likelihood of the correct labels. But since in OpenQA setting we have intermediate variable uh, which is given by the document retriever, given an input question. So just to make clear again, we're given a question X, uh, retrieved documents retrieved documents Z, and the final answer Y. We know here that we can't directly get likelihood of the correct answer or final answer here, because there is an intermediate variable present here, which is the probability of retrieving a document, specific documents. And in the last video also we discussed about how if for each different retrieved passage there is a different chance of getting a final answer. Let's say our document retrieves for the same question what are the total number of rocks. To get the correct answer 110, it's much more likelier to get the answer from a document that is talking about rocks, rather than a document which is talking about presidents. So since this intermediate variable comes in order to get the likelihood of final answer, we have to consider the marginal probabilities. To discuss about marginal probabilities, just to give, I'll briefly talk about them. Mar- sorry. Marginal probs. So marginal probability is the probability of an event unconditional, or we can say unconditional probability of an event or a variable irrespective of any intermediate variables that could be there. So in later in our case we'll see how we marginalize over the set of documents. But before that, a very quick and small example. For here, let's take two discrete random variables. One random variable could be regarding a disease, and the other one for symptoms. So this random variable can have either a value of 0 or 1, or value of 0 or 1. So 0 represents that the disease is absent. 1 represents that the disease is present. Similarly, for symptoms, 0 shows the absence of symptoms and 1 shows the presence of symptoms. So let's take a small example here of So for our use case, we can simply take the case where the disease is absent and symptom is also absent as a probability of 0.5. Then we can take the case where the disease is absent but the symptoms are there. It can be 0.1. Similarly, when the disease is there but symptoms are absent, then we can all take here 0.1, and when both disease and symptom are present, the probability is 0.3. So each of these blocks shows the presence of, the presence of either presence or absence of these random variables. So a natural question comes like, how do we say that what is the probability of disease? What is the probability of this random variable itself? So to get that, we have to marginalize over the intermediate variable, which is symptoms here. So to get the combined probability or the unconditional probability of what are the chances of someone having a disease, that is nothing but zero point 0.1 plus zero point 0.3 in our case. Similarly, what is the disease equal to 1? Similarly, what is the probability of not having a disease will be marginalizing over these variables. So similarly, in an open QA context, we know that for one particular question, we retrieve, let's say here in our case, 5 blocks, and then from each of these blocks we get looking for what is the answer, or what is the probability that our QA model gives to the gold string. So continuing on the same example, what are the total number of rocks? Total number of rocks, and the answer 110. So we want to see what is the probability of 110 given by each of these models. So for this particular retrieve document, let's say the probability is something 0.1. It won't be this easy to so and for this is 0.3 or something. And so the idea is we have to marginalize over all these intermediate documents that we get, and each of these documents also get their own probabilities from the retriever. So this document might have a probability of 0.2, this might have 0.3, the others might have 0.11, that way. So if we remember the OpenQA, the final probability of a final string given an input x, summation over all the retrieved documents, which is, so this probability will depend on x times probability of this final answer string that we are looking for given x and z. So what we are doing here, similarly like we were here marginalizing over symptoms for disease equal to 1, here also we are marginalizing over all the documents. So this gives us the probability of from different documents, what is the probability of finally getting the answer equal to 110. So if you see, now we going back to marginal log likelihood. So marginal log likelihood was nothing but marginal probs of correct answer. So if you put this here in the equation, it becomes minus log summation over z p of z given x times p of y given x comma z. Okay, so generally probabilities that are involved here are very small numbers, so we generally try to avoid doing multiplication of them. So this entire thing is actually done in log space. So if we take log of this simply becomes log of p of z given x plus log of p of y given x and z. And since we are taking log, and we then will have to take an exponential here so that the values are numerically correct. So and by the way, these values we get by doing log softmax from the retriever. Will give whatever probabilities that we get from retriever, we take a log of them. And continuing here, so it is a sum minus log. So if you see here, what is happening is it is log sum exponential, sorry, log sum exponential is happening. So whenever we try to implement and try to get the values of what will be the marginal log likelihood for this particular answer, we use this function. It is present both in TensorFlow and PyTorch. And usually what we do is we do marginalization over the set of documents. So we'll be doing this in the dimension of documents, but that is something we'll see in further videos in the where we discuss about the different paper implementations. So this is it for this video. Thank you.